Okay, now what we'll find is rates of change, they're very rarely constant, all right? So for example, let's say you're driving your car at 50 kilometres an hour. Even if you've got it on cruise control, it's not going exactly 50, there'll be slight fluctuations in the road surface and there's a gust of wind and all of those affect the speed of the car. It's never going exactly 50. And so the rate of change is not exactly constant. There's all these slight fluctuations, right? We've got an example here where we've got beetles, the number of beetles and how much poison we're using. Obviously, the more poison you use, the more the more beetles are going to die, right? The more we can get rid of them. They're eating up our lawns, so we want to get rid of the beetles. Okay, now we can't calculate the rate of change here because it's not constant. We can see because it's not a straight line, it's not constant. In fact, the rate of change is changing. So we're asked to calculate then what we call the average rate of change, which is an indication of the rate of change, but occurs over an interval. So we've got the number of lawn beetles per square metre surviving in the lawn after various doses of poison is given in the graph alongside. Estimate the average rate of beetle decrease when the dose is increased from 0 to 10 grams. So here the dose is 0, all right? And here the dose is 10. And we want the average rate of change over this interval. All that means is we want the slope of this line as an indication of the rate of change of that interval, okay? So we call it the ARC, the average rate of change, and that's just equal to the slope over this interval. This coordinate here is x is 0, y is 35, and this coordinate here is x is 10, and the y value is 5. All right, and so same again, x1, y1, x2, y2, and we do our y2 take y1 on top of x2 take x1. Now I've said it's always y per x. So on the y-axis we've got beetles, and on the x-axis we've got grams of poison. All right, so for each gram of poison that you use, on average, you're getting rid of 3 beetles. Okay. Part 2, how about when the dose increases from 4 grams to 8 grams? So 4 grams is like here, and 8 grams is here, and we want the average rate of change over that interval. We're finding the slope of that line. So we've got when x is 4, and when x is 4, the y value is 25. And then this one here will be when x is 8, the y value is, that's going to be tough, what do we reckon, 8 or 7? There's a bit of estimation involved in that one because it's not very clear. We'll say when the dose of poison is 8 grams, the number of beetles is 8 beetles. Okay, and then we repeat it. y2 take y1 on x2 take x1. So the AROC from this interval will be 8 take 25 on top of 8 take 4. So what do we got? Minus 17 on 4. What's that? 4. 2, 5. Beetles per gram. Now, we can see we expect this number to be higher because just based off the graph, this chord is steeper. It has a sharper slope. And so the poison has more effect over this interval. And then you can see the more and more poison you add, that effect sort of tapers off, doesn't it? And this is the case, like whether you're using weed poison or whatever you're trying to do, it doesn't matter how much Roundup you use, there is a point where the effect tapers off. Okay, last one. Part B, describe the effect on the rate of beetle decline as the dose increases from 0 to 14 grams, the effect on the rate of beetle decline. The rate decreases, all right? So the rate starts off really highly, but as you're moving along, see how it plateaus out here and it gets flatter and flatter and flatter? Adding more poison has less effect. The rate decreases as you add more poison. That's all we need to say for that last part. Excellent. So that's enough for you to get into exercise 4A.2. This will be where we spend the grunt of today's lesson. If we can, it would be good to move on to 14B, but we'll see how we go having a wrestle with this. Questions are at the front with the checklist there for differential calculus. So question 1, 2, 3, and 4.